Hi all of you. Today our topic is StatPro V. What is StatPro? StatPro is a structural analysis and design program. V8 means version 2008 interactive. In that we have to first open the StatPro files like here we see project tasks. In that first we go to configuration, click on it. Here there is the options you have to change. Like we change the units as a metric. Design codes. In design codes, we have to use steel for IS 800, concrete for IS 456, etc. Apply on it. Next, we have to open new project. In that, choose option as test. We have to give the file name as something. In that, we have to save the location file as downloads or desktop, whatever it may be. Next admin, finish. Here open your file now of the grid. Here we have to see all the commands of StatPro. This is a front view, back view, side, right and left, top and bottom, isometric rotations. All commands are here. This is add beam. This is nodelets. Nodelets all are used. First we have to start the building design as a G plus 5 or G plus 10. Actually, what is structure? Structure is a combination of slabs, columns, footings and slab. First we have to take beams and columns like from frame models. There is base frame, double click on it and the apply length is 12 meters. Next height is 3 meters. View the first for one floor, apply on it. Here you have to see the dimension. Yes. Okay, click on it. Here we have the ground floor. Then our next step is to take a steps. So how to draw a steps? Take top view of the structure, cut section, select one corner, you select it. Next we have to see only the highlighted area. That's it. Okay on it and change it as isometric. Yeah. Next, select the two columns. Give a right click, insert your name, add midpoint. Okay. First of all, you have to take the midpoints on it and change the midpoints as take the node cursor. This is our node cursor, this is plate cursor, this is beam cursor. Select the two nodes with control. Copy the nodes, paste the nodes as control C and control V. How much distance we have? Minus 0.8. Okay. Yes. Next, take the add beam section. Add the beams. Click on it. Select those two beams, give a right click and give a midpoint of it. Okay. Next, we have to copy this node from here to 3 meters below. That means minus 3. -3 in y direction. Control C, control -3 in y direction. Okay. Next, take the plate cursor, view the plates for steps. Our steps are completed here. Next, complete structure visual disorder. Next go to translation repeat. We want floats on that. So how many floats we want? Okay, 10 floats. 10 floats with the height 3 meters. Okay. Sorry. Okay, here we have to take a plate section for a slab. View the corners where you want. Next go to translation repeat. View a y direction G+10 building with a height of 3 meters. Right? Okay. Here we have to select the first. Take a beam cutter and select a movie section. Translation repeat. Okay, here there is a G+10 building. We have to translate only the beams. Next we have to translate the slabs like plates. You take a plate cursor, select the plates and go to translation repeat. This is also in y direction because of floor. Okay, 10 floors with 3 meters height. Okay. Okay. Here we have a rendering view to show slabs and building. This is our building and rendering. Okay. First we have to design a building in geometry. Next we have to go to general. There is the options for properties, supports, load definitions and materials. We have to take in step-by-step process. Property we have the options of define and then go to rectangle. For beams take 0.35 like 0.3 or 0.35 for your beams. Add it. Next for columns 0.4 like 400. Add it and then close. Next there is a thickness for a slab. Slab 0.15 or 0.12. Add it and close it. Next, apply it step by step. First we have to select the rectangle 0.35, 0.35. Here there is an option for select. Go to beams parallel to x-axis and select beams parallel to. Here option of assign to selected beams and assign it. Yes. After select the columns for 0.4, go to select option. There is a beams to parallel to. Columns are in y direction. So select assign to selected beams. Assign it. Click on S. Next, thickness of the plate. You have to select the thickness. All slabs are selected. and assign to selected plates, assign. Click on yes. Yes, our building have the properties of all beams, columns and slabs. Here we have to see the rendering view of the structure. This is our building along with the steps, G+10 building rendering view. Okay, our first option is property, it will be completed. Next, you have to give the supports for a building. Click on supports and take a front view of the structure. Take the front view of the structure. Next, there is an option of create. Take the fixed support, add it. Okay, there is a support. Please select to that and take the nodes of the building. There is the option of assign to selected nodes and assign it. Click on S. Here we have to apply the supports of the building. Go to isometric view. Yeah, all the supports are assigned. Next, our first property is completed. Next is the supports, it will be completed. Next, loads and definitions. In loads and definitions, we are applying which type of loads, like dead load, live load, seismic load and wind load. What is seismic load? Seismic load is a earthquake load. How do we resist earthquake loads by this? Next, seismic definitions. Add it. Here we have the parameters for seismic. Use the UBC as yes. Here seismic parameters, we have the options of Indian IS 1893, 2002 or 2005. Just click on it. Next we have the parameters which we have changed. Go to choice of Hyderabad. Here click on generate and apply city as Hyderabad. H and then click on hot soil. Okay. Damping ratio is damping ratio is 0.05. View all techniques here and remove. Then we have to change here 0.05. Next go to self-weight given as 1, add it. Next membrane weights is due to UNI. Weight of the object is due to dimensions of the beam into brick density. That means we have to take the beam dimensions as 0.3 and 0.3. 0.3 beam dimensions will be 19, brick density will be 19, so total will be 1.71. Then add it. Next flow rates will be load pressure. In flow, what is load pressure? It will be slab dimension 0.15 into concrete 25. It may be 3.75. Okay, click on it, add on it. And close. Next, go to wind definitions, add it. Wind load 1, taken 1 and close it. Next, load case details. You have to minimize it and go to load case details. In load case details, add first taken as dead load. When we taken these loads are in sequence, we have to decrease our errors. So First you have to select the seismic loads, then wind load, then live load, sorry, dead load and live load. Okay, here we have to select the seismic. Seismic we have to give the title as EX, that means earthquake in X direction. And next earthquake in Z direction. In Z. And next take in wind load, wind in X direction, wind in Z direction. WX and WZ and next dead load. Dead load means DL. And live load and close. So we have the sequence of earthquake, wind, dead and load. So select EX, add it. Here we have to open the one options like self-made. In loads and definitions, seismic loads, we have to select the seismic loads factor as 1 in each direction, add it, and -1 for opposite direction in each direction, add it, and close it. EX will be completed. Next EZ, add it, go to seismic loads. Here we have to apply the seismic load in Z direction. So select Z, factor is 1, add it. Next in opposite direction, -1 will be added, and close. EX and EZ will be completed. Next wind load. Wind load in X direction. Go to wind load. Here you have to select the direction as X and factor shift will be 1. Minimum direction for wind will be applied above 10 meters of the building. Our maximum height of the building is 33. Why? Because it is in G plus 10 building. Per floor it may be 3 meters. Next add it. Next same wind in X direction in the opposite direction. That means you have to take the -1 and add it. Then close. Next wind direction in wind in Z direction. Go to wind load, take the direction as Z, factor shift will be 1, minimum distance will be 10, it will be 33, -1. And next wind in opposite direction, -1, and close. Next Z load. Here we have to open the self load and Z load. Self load will be -1 in Y direction. Add it. Next member load. Member load will be in member load. Take your uniform parts. It will be wall thickness into height into brick density. Total 13.11. Add it. And close. Next live load. And in live load we have to take the floor load. In floor load, the thickness of the slab into density of the concrete. Total 0.15 into 25 will be 3.75. Minimum distance will be 3. Why? Because our slab will be 3 meters to 30 meters. And it. And close. Next you have to assign the slots. Just select assign. Next select the load. Use assign to view. Assign. Select the load, assign to you, assign yes. Yes. Here you have to select each load. We have to see the difference of the loads which you apply. Wind in x direction, x in y directions, wind in z direction, self-weight, live load. After the load and definitions, we have to go the materials. Just click on concrete, assign to selected beams, assign. Click on S. Okay. Our general options will be completed. Next, go to analysis and print. No print option, add and close. Go to run analysis. Save the structure. You have to see the errors and warnings here. Okay, here we got 0 errors and 0 warnings. Then next, go to design. Here we have to give the dimensions for a bars which were used in beams and columns. There is a define parameters. Click on it. Go to select the parameters. Click on it, and here we have to select the FC, Fmin, Fsec, max, FC, Fmin, Fsec, maxmin, maxsec, MD1, MD2, minmin, minsec. Here we have to select all those options and click on OK. Then go to define parameters. Here you have to select the FC, give the FC as 30,000. Click on add. Next go to FIMain. FIMain as 5 lakhs. Click on add. Next FSec as 5 lakhs. Click on add. Then maximum. Maximum will be taken as 25 minutes. Click on add. Maximum will be 35. Click on add. MD1. MD1 is for assumptions 16 minutes. MD2 will be 16.